Welcome to ClickMyProject.com. Now we are going to discuss about the project Reversible Data Hiding with Hierarchical Embedding for Encrypted Images. Now we are going to discuss about the abstract of the process. Data hiding is the process for embedding the message into the covers in any multimedia files such as the image file, audio file, or else the video file, or else any other files. The data hiding denotes the hiding the information or else the keeping the information very secret, which is used for on the person who is authenticated or else the person who is having the appropriate key with them. Reversible data hiding in encrypted images has attracted the considerable attentions from the communities of privacy, security and protections. Hence, in this process, we are using the data hiding techniques to hide the data as well as to prevent the data by using the encryption methodology. On the recipient side, additionally, message can be extracted from the marked encrypted images and then the original images can be recovered without any errors. Errors in the sense loss of the pixels. So without loss of the pixel in the sense there is no error in the retrieved side. Reversible data hiding in encrypted images has got some promising application in the cloud storage, medical imaging and then the other forensics departments. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. The project consists the modules such as the input image, pre-processing, key generation, encryption, decryption, then finally reconstruction. So this is the overall modules present in the project. At first, the input image is taken from the dataset. The dataset consists the lot of images which having the both the of JPG format or else in the PNG format. After getting any one image from the dataset, we just move to the pre-processing stage. In this pre-processing stage, we are going to apply the image resize. Why we are going to use the image resize in the sense, for example, there are a lot of images in the datasets which having the different type of rows and columns. So we have to resize the image into an aspect ratios in the size of 256 cross 256, which means the number of row will be the 256 and then the number of column will be the 256. After resizing the image into an optimum size, we have to generate the key. So the key is generated as well as the user can give the secret key. So these generations will be done here. After that, the next module is the encryption side. In this encryption side, we are using the reversible data hiding method to encrypt the image as well as we have to embed the data. For example, I have one image. I have to encrypt that image as well as the data in the sense it will be in the form of string values, texted string values. So the text data will be embedded into an image, then the image will be encrypted. After the generating the encrypted image, we have to again give the input key. For example, the key value is 123 in the sense we have to again enter the appropriate key value 123. If the key is correct means it will go for the decryption side, or else it will again ask the user to enter the appropriate key. So after applying the appropriate key, it will move to the decryption side. In this decryption side, the reverse process of the encryption will be done to retrieve the original image as well as the original data. First of all, the encrypted image will be the input for the decryption side. After that, the decrypted image will be shown. After the decryption, the embedded data will be extracted, that is in the part of reconstruction. Finally, the output image as well as the output data will be generated. Finally, the performance of the process will be estimated by means of the performance parameters like PSNR and MSE, pixel to noise ratio, mean square error. Now we are going to discuss about the running procedure of the process. At first, open the Matlab 2015B and change the current directory. If you want to execute the process, just right click in the mains _GUI.m and right click and then you just click the option run. Now the user interface was open. In that user interface, you can see the several push buttons and then the several displays here. So first of all, click the button input image. After that, you have to open the dataset folder, then select any one image from the dataset. After the selection of the image from the dataset, the corresponding image is shown in the axis 1 with the title of input image. then we have to do the pre-processing. So in this pre-processing we are doing the two things. One is the image noise filtering as well as the image resize. So the image will be resized into 256 cross 256. If the input image is already the 256 cross 256 means it will remains the same, and then the filtering is applied by using the Gaussian filtering method to remove the noise present in the image. If any noisy pixel is present in the image, it will be removed. After that the user can give the key like this, then click the button encrypt image. After clicking the button encrypt image, the image will be encrypted like this. The encrypted image will be looking like this. After that we have to again give the key for loading the data. So here we are loading the data like this. Then we have to encrypt the data. So the encrypted data will be looking like this. After encrypting the data, we have to save the data in the separate folder. Now I have saved the image in the name of encrypted.bmp. Now we have to click the button, next button. Now the new user interface was open. In that user interface, this is the decryption side. In that we have to again enter the appropriate password and then give the submit button. We have to again load the encrypted image here. So after loading the encrypted image will be decrypted automatically. Then the decrypted image will be shown in this axis. After that the performance of the process will be evaluated by means of the PSNR DMSC. Those values are plotted in the bar chart format here. Then the appropriate values will be shown here. 46.5 for the PSNR and 1.4 for the MSC. Then we have to enter the password to retrieve the data. So the retrieved data will be looking like this. Then we have to retrieve the original data. Original data will be looking like this. Thanks for watching this video.